Welcome to Stats 1 class. Today I'm introducing you to how to do a few tests. First of all, the test for whether two events are independent, whether they don't impact each other. For example, if we roll the dice, getting a 6 on the first time of rolling the dice does not impact when you roll the dice a second time as to whether you get another number. It has no effect on that, it's independent. However, imagine if you had some counters in a bag. Let's say you had 3 red counters and 1 yellow counter. Now if you selected a red the first time and pulled it out and didn't replace it, and then when you go to take a second one out, that event is not independent because you have already taken one out, so that changes the probabilities of taking a red or a yellow out, in fact. So those two events that would not be independent in that case. I hope that gives you kind of just a sort of a concrete example of what we're talking about here. Now the test that we use for this is if two events are independent, so let's call the event one event F and one event V. If they're independent, the probability of V given F is going to equal the probability of V. Now let's think about why this might be. We know that the probability of V given F is equal to the probability of V intersection F divided by the probability of F. So let's now make this concrete by considering V and F as the following. V is equal to getting a heads on second throw of a coin. F is equal to getting a tails on first throw. Now let's consider V given F. In other words, that we get a heads given that we got a tails on the first throw. So that is equal to V intersection F divided by the probability of F. Now we know that this means both getting a heads on the second throw and getting a tails on the first throw. So it's this particular branch here, and that's a half times a half, which is 1/4. And then if getting a tails on the first throw, the probability of that is a half, because there are 2 branches, both each of them a quarter, so it's divided by a half. Now a quarter divided by a half is equal to 1/4 divided by half is equal to 1/2. At this point we can decide whether they're independent or not. The probability of getting a V on a second throw of the dice is this one here, which is 1/4, and this one here, which is 1/4. They add together to be a half. So we see here that the probability of V given F is a half, and it's equal to the probability of V being a half. So since this is true, we know they're independent. In other words, this getting a heads on the second throw is not affected by getting a tails on the first throw. The probabilities are not affected by each other. Also, the second law that we want to learn is the addition law for probabilities, and this is what it is. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Now again, sometimes it's helpful to look at a Venn diagram for these. So here's our Venn diagram. This is A, this is B. So the probability of A and B, getting anything from those, is equal to the probability of A, which is shaded this bit here, plus the probability of B, which shaded is this bit here, and then minus the probability of this bit here. And you see why that is, because we've counted this bit twice in the red and the black. So we've got to subtract one of those bits to just get the overall probability of anything that's from A or B. So that's the second law that we're working with today. Okay, and this leads us to our third law, the law of mutual exclusivity, or whether two events are mutually exclusive. In other words, that if one happens, the other can't happen. So the rule for this is, if the probability of A or B, or A union B, is equal to the probability of A plus B, then it must be mutually exclusive. And the reason for that is, if we go back to our Venn diagram again, here's A, here's B. If the probability of A union B is equal to all of this plus all of this, then they must be mutually exclusive, because that means there is no overlap that needs to be taken away. I hope that makes sense. Now let's try for a few concrete examples. The first example I'd like to share with you is the first one in the exercise. We are given this information. We are given that the probability of A is equal to 0.7, and we're given the probability of B is equal to 0.4. And we are told that these are independent events. The first thing we have to find is P, A intersection B. In other words, we want to find the probability of A intersection B. Now, if these are independent, we know, so if they're independent, we know that this, A given B, is equal to the probability of A, given the law that the first law we learnt today. And we know that this is equal to the probability of A intersection B over the probability of B. Now, what do we know here? We know the probability of B, and we know the probability of A, but we're trying to find out the probability of A intersection B. So simply we just use algebra, and we're going to say that the probability of A intersection B will be equal to the probability of A multiplied by the probability of B. And in this case, that's 0.7 multiplied by 0.4, which is 0.28. Okay, so we'll write this up here. Probability of A intersection B is equal to 0.28. Okay, now let's move on to the second question. The second question requires us to find the probability of A union B. Okay, now this is our second law. We know that this is equal to the probability of A plus the probability of B, subtract the probability of A intersection B. Now what have we got? We've got that, 0.7. We have the probability of B, 0.4. We have just worked out the probability of A intersection B. When we add this all up, we get 0.82. So that's the second question. Now we'll have a look at part 3, or part C, sorry. This time we're trying to find the probability of complement of A where it intersects with B. Okay, the complement of A where it intersects with B. Now, we could just think about this in terms of Venn diagram. So, here's A, here's B. We are trying to find where not A intersects with B. Now if you think about not A is this bit here and this bit here. But where does not A intersect with B? It's just talking about this bit here. So to find that purple bit there, all we need to do is do the probability of B, the whole probability of B, and subtract this little bit in here, which we know is the probability of A intersection B. Now the probability of B is 0.4, and subtracting the probability of A intersection B is 0.28 from up here, and thus altogether we have 0.12. Look, I really hope that gets you started on this exercise. If you're having any trouble with it, as usual, please email me and I'll be able to give you a few tips and maybe even a video to help you with the ones that you are unable to do. Good luck!